Okay, so there's different types of motors as well. So Michael's going to explain to us different types of motors that you can use.
So we have continuous servos, which don't have control over the precise degree that you're at, but they do have a speed and direction control.
Okay, so this is something that you would spin, like for example, if you're going to spin a wheel.
Right,
and you
exactly.
want to spin it at a particular rate. And the nice thing about a servo control is inside of this mechanism, there's both the motor, but there's also a little controller in here.
Mm-hmm.
And so from, like, for example, an Arduino, you would send a signal that says spin at a certain rate. And the internal controller will make it spin at that particular rate.
Exactly.
So they have servos that spin at rates.
And servos that go to certain degrees, but they're limited. It's 180 degree. So you can go 0 to 180 degrees, and you can tell precisely what degree to go to. So if you wanted to control a flag or a robotic arm and tell it exactly where to move, you would use a 180 degree servo to do that.
So you got servo motors. Servo motors are really easy to work with because you don't have to worry about controlling them.
Stepper motors, on the other hand, you have much more, you have a lot more power, and you have a lot more, you do have precise control as well as speed control, and they're 360. The one problem is sort of twofold. First, they're a lot heavier. You do need to have a separate motor controller or motor driver, and also they do not have a universal 0, so you'd have to have some sort of reset to tell you when you're at your starting position, like a limit switch.
But a stepper motor, you can tell it, okay, step a certain step, and it will precisely.
So this one has probably 200 steps per rotation or per revolution. So you could tell it to move, 1.8 degrees per step. So you could say, I want to move it 1.8, another 1.8, another 1.8, and kind of move through that circle.
Okay. And you have the drivers that would be used to control a stepper motor.
We have these LM298N, and these will drive stepper motors as well as DC motors. So if you wanted to make a remote control car, this is a really easy way to do it. So you can have your power system through here to drive it back and forth, and your steering motor on this one to turn it left and right.
Wow, awesome. Okay. So we have servo motors, we have stepper motors.
We have DC motors in here. So whether you wanted something just hook up to a fan like this, if you wanted something with an encoder on the back so you still have that precise control.
So a DC motor, you basically apply a DC voltage and it will spin at a rate.
Exactly.
At a certain rate. And then an encoder here on the back, this encoder tells it where either the rate, or it tells you essentially where the motor is.
Yep. And so through doing that, just like with a stepper motor, you can use that to move in precise amounts, but it's 360, so you're not limited like you are with a servo.
Okay, and then a DC motor, there's also motor drivers, so that same chip you were showing us can be used with the DC motor to drive
that. Can be used as something as complicated as this, or as simple as this little 60-cent DC motor that you just hook up a positive and negative voltage to, and it spins at a much higher rate, but a lot less torque.
By the way, this thing at the end of this motor here, this is a wheel that we use for robot soccer. It will, so I guess I could demonstrate it here on the ground. It'll translate like this way, but also move in this direction because it's got these little wheels on top. So kind of a clever little idea. It allowed us to make robots that would move in any direction. Okay, so that's DC motors, and then there's something called an AC motor.
Let's look at this example. So this AC motor is cleverly disguised as a fan. It operates at 60 hertz with 120 volts. So you would plug this into the wall and you would get a lot higher power, a lot higher speed and a lot higher power. However, this would not be able to run unless you had an AC voltage coming into it. So they rely on that alternating current, that plus and minus, in order to push and pull the magnets on that motor coil and drive it forward or drive it backward.
Okay, so AC motors are much more complicated to control, but allow you to plug it into the wall, basically.
And a lot more power.
and get a lot more power out of them.